what I was asking you in 20 part 3 is by then x equals 6, okay? Verify that n plus 1 factorial divided by n minus 1 factorial equals n squared plus n. So, Sean, how did you go about doing that one last night?
I got 7 factorial over 5 factorial.
And how did you get 7 factorial in the first place?
I plus 6 by 1.
Okay, so
7 take away 1, or 6 take away 1.
So anywhere Sean saw an n, he replaced it with a 6. Okay. 1 second there, guys. Let me lift him up slightly. He replaced it with a 6, so it's going to be 6 plus 1 factorial divided by 6 minus 1 factorial, and that's going to be equal to 6 squared plus 6. Is everybody happy with that?
Mm-hmm.
And then all I have to do is get 7 factorial divided by 5 factorial. So for those of you who are probably mainly Gonzalo there, there's an exclamation mark button here. You see it here in the yellow. So you do 7 shift that button there, divided by 5 shift that button there, and you get 42. Okay, so this here is 42, and then on the other side we're going to have 36 plus 6, which gets us 42 as well. So 42 equals 42. You've proved that it's right. An answer like this won't be in the back of the book. Can anybody explain why? Verify that, show that, and prove. All these answers never make the back of the book, because if it balances, you know you're right. Okay? Now, 23. In how many different ways can 8 horses win a race? So, if there's 8 horses in a race, that means how many positions do we have? 8. So, you're right. I just want to continue to just draw the boxes just to... You don't. Eventually you don't, but I just want to explain where the numbers are coming from. A choice... What? One back space. A choice of 8 horses can come first. When a horse comes first, there's 7 horses left for second place, 6 horses for third, fourth, fifth, and then all the way down to 8. That's how many places the horses can come in. You can have 8 in first. Once you choose a horse, there's 7 horses left for second position. You got to multiply all these numbers by each other to find out how many different ways can the race end. We could do this in the calculator, but there's a quick way of doing it. It's called 8 factorial. And 8 factorial is 40,320 different ways the race could happen. Okay? So 40,320. There are 2 very slow horses in the race. They always finish last and second last. How many different orders can the 8 horses now finish the race? We had a similar question to this before, didn't we? We treat the last 2 horses as what? We treat them as one box. Okay? So so what we do is we now, instead of having 8 horses, we now technically have 7. It's just a way of thinking about it, okay? There's 7 positions, if you will. We'll call it positions, okay?
It's not 6 horses of 2 more.
Oh, sorry, 6. You're right. Okay. So whatever happens here, right? These 2 horses have to be in this slot here, and 2 of them are gone. That means you have a choice of 6 for first place, a choice of 5 for second place, 3, 2, 1. Okay? This here is how many? That is 6 factorial, and you have to multiply that by 2. Because remember, the 2 horses can switch positions. The last and second last horse can change positions on each other. And what do we get there? 1,440. Is that alright? Sean?
I did 6 factorial for something.
One suspect and 8 members of the public are taking part in a police identification parade. So we're talking about 9 people in total, right? Because one of them's a suspect and 8 regular punters, right? How many different ways can the 9 people be arranged in a straight line? 9 people in a straight line? 9 factorial. It's 9 by 8 by 7 by 6 by 5 by 4 by 3 by 2 by 1. What's 9 factorial?
362,880.
You alright with that, Dennis?
Yeah.
Okay. They're assigned they're assigned an order at random. In how many ways can the parades? How many of the parades is the suspect either first or last in line? Okay, here's what we're going to do. We're going to write down all 9 slots. I do like this. I'm a visual learner, so what I'll do is I'll always draw. Okay, some people don't have to. I do. And it's always served me well. 2, 3, 5, 6, 7, 8, 9. Okay. Just 2 scenarios. So what I'll do there is it could be alright. Yeah, I actually think it probably will be. Yeah. To be fair to you, you're probably faster than this than I am at the moment, because I always have to draw diagrams even when it's easy. Now, what happens is the criminal can come first in one of them, and he can come last in the second one. And what Mick was saying is correct. You just that's the rest of the order there. Is that 9 of them? So I drew 1 too many, didn't I?
No, you got 4.
I forgot 4. Okay, even worse. So 4, 3, 2, 1, and we know that's a factorial, don't we?
Is that like the random?
What?
Is that like at random?
No. Your man has to be here. He either has to be first or last. So in this one, I'm forcing him to be first, and in this one here, I'm forcing him to be last. And then we have 8 people left over. 6, 5, 4, 3, 2, and 1. That's another 8 factorial. So what Mick said is correct. 2 multiplied by 8 factorial is anybody?
80. No, it's not 8 factorial. 80,640.
What?
It's not 8 factorial.
Is, which is the same thing as 2 multiplied. It's the same thing.
Right, 80,640.
8,640. How many people got that out last night? That's pretty good. Well done, lads.